functions are defined differently over different domains. These are known as piecewise function. One of the most well-known piecewise function is the absolute value function. How we proceed depends on the input, if it's positive or negative. Defined in this manner, this is how we write the absolute value function. This says that if the input is greater than or equal to 0, we do not do anything. We keep the number as it is. For example, the absolute value of 2 is 2, the absolute value of 5 is 5. However, if our input is less than 0, we need to change the sign. If our input is -3, we need to make it +3, etc. So this is the idea of a piecewise function. Let's consider another one. Let's think about a company that gives rides on a boat. The company charges a $100 flat fee for the first 5 people, and an additional $25 for every additional person after that. This would be a piecewise function because the cost depends on the number of people riding in the boat. This is how we would write the piecewise function for the boat ride. The first part states that if we have between 0 and 5 people, including 5, we would be charged $100, and that doesn't change. The second part addresses if we have more than 5 people, we have to pay the initial $100, plus an additional $25 for every person over the first 5 people. So the x minus 5 tells me how many more people I have over 5. Multiply that by 25 and add 100. When we graph a piecewise function, we need to consider the domain restrictions. So let's think about this function here. We want to start with the first part of the function, -x plus 3, but this is for only values less than or equal to -1. The easiest way to graph a function is to make a table and plot some points. When we do this, we do need to make sure all of our inputs are less than or equal to 1, so here I picked -1, 0, and 1, and we're going to plug these into -x minus 3. -1 minus 3 would be -2. -0 minus 3 is -3, and -1 minus 3 is -4. Next, we'll plot these points, -1, -2, 0, -3, and -4, or 1, -4. And from there, we'll plot the points, connect the dots, but we only want to connect for numbers that are smaller than 1. So we will not extend this to the right, but only to the left. Since this boundary does include the point -1, we need to have a closed dot at that point 1, -4. Next, let's look at the second half of the function. This time we need to pick numbers greater than 1. And even though we don't directly include 1, it is still important to have 1 and numbers bigger than 1 in our table. So we will use the numbers 1, 2, and 3. 1 squared minus 2 is -1. 2 squared minus 2 is 2. And 3 squared minus 2 is 7. Since x equal to 1 is not actually included in the second part of the function, when we graph the point 1, -1, we use an open dot, and that indicates that this point is not part of my function, but it is still important. We then do 2, 2, and 3, 7 goes off my graph here. And we then connect with this smooth curve. So my piecewise function looks like this.